So the last topic of module 1 section 2 amplifiers is your multi-stage amplifier. So what is meant by a multi-stage amplifier? If we want to increase the gain, then we can go for different stages of amplifier. So multi-stage amplifier is basically used to increase the gain or to increase the strength to a great extent. Okay, so if we are not able to achieve the amplification within one stage, we can go for multiple stages of amplifier. Okay, so the overall gain of the amplifier, so let me draw the diagram first. So if this is your stage 1 amplifier, this will be your input to the stage 1 amplifier. The output to the stage 1 will be fed as the input to the stage 2 of the amplifier. Okay. Now, the output of stage 2 will be the input to the stage 3 amplifier. It goes on till stage N amplifier. Okay. So this will be your final V out. So this suppose let us assume that this is your stage 1 amplifier with a gain of AV1. Stage 2 has your gain AV2 voltage gain. Stage 3 has AV3 etc. up till your stage N has the voltage gain as AVN. Okay, then the overall gain can be given as AV will be equal to the product of all individual gains. Okay, AV1 into AV2 into AV3 into etc. up till AVN. Okay, so this will be your gain of your multi-stage amplifier. Okay, now there is one disadvantage. Okay, disadvantage. So I have told that the gain increases, but at the same time when the gain increases, the bandwidth decreases. Okay, now for example, let us take the frequency response. So frequency, hertz, gain. We take the voltage gain. So if this is your gain or frequency response of your first stage, okay, first amplifier, if I take this as F1, FL1 and FH1, okay. Now as we increase the stages, the bandwidth keeps on decreasing. So this will be your FL2 and FH2. Similarly, third stage it will be FL3 and FH3. So as your gain increases, the bandwidth decreases. These are one disadvantage. This is one of the disadvantage of your multi-stage amplifier. Now let us see the next topic in multi-stage. So if we want to use multi-stage amplifier, we want coupling, right? Here your stage 1 is connected to the stage 2 by means of coupling. So there are mainly 4 different types of coupling between individual stages. Coupling between individual stages. So what are those 4 types? Okay. So first one is RC coupling. So the name itself gives you the meaning. Okay. Second one is called LC coupling. Third one is called transformer coupling. And the fourth one is called direct coupling. Okay. Direct coupling. Okay. So what is the meaning? RC means you have resistors and capacitors. Resistors and capacitors as coupling elements. LC means inductors and capacitors. Okay. LC. Transformer means, transformer coupled means transformer will be the coupling element. Direct coupling, it is also called as DC coupling. Directly you are going to couple the one stage to the next stage. Okay. If you want to for example, if you want to amplify even 0 hertz signal, then we go for this DC coupling method. Okay, so the diagram of the RC coupling is given as, so let me give the diagram. So the input stage, you will be having both your capacitor as well as your resistor will be fed. This will be your V input, which will be given to the first stage. Okay, now the second RC will be this will be R will be connected to the supply voltage. RC will be given to the input to the second stage, and it goes on. Okay, again you have R connected to the same supply. Along the C will be getting the output V out. So first stage, second stage will go to the common connection, that is nothing but your ground. Okay, now similarly, if you see LC coupling, what will be your diagram of LC coupling? Instead of R and C, here you are going to use L and C. Okay, so this will be your V in inductor. Okay, it is given to your first stage. Inductor will be connected to the supply. Then you have your C, which is fed as input to your second stage. Okay, VCC. VCC is nothing but your supply. Okay, now LC, here also you have LC, from which you will be taking your corresponding output. So it is for two stage. Similarly, what will be the diagram for your transformer coupling? Instead of LC, you are going to use the transformer. So this will be your input to the primary of the transformer, right? So this will be your T1, which will be given to the first stage. Now again the transformer, this will be connected to your VCC. This will be your transformer T2, okay, which will be fed as input to your second stage. Again you have your transformer T3, from which you are going to take your corresponding output. Okay, this will be your ground, your VCC. Okay, now what is happening to your direct coupling? So directly you are going to connect the input to the first stage. VCC. Again it is directly connected to your second stage. Okay, so you will be getting the direct output V out. So these are the 4 different types of coupling used in the multi-stage amplifier. Okay, so the next topic is your 2-stage RC coupled amplifier. So it is 2-stage RC coupled amplifier. RC coupled amplifier. This is the example given for your multi-stage amplifier. So how will you draw the diagram of your 2-stage RC coupled amplifier? So what will be your construction? You will be having 2 transistor T1 and T2. Okay, here the best suitable configuration which is used is a CE configuration, CE amplifier. Okay, so let me draw the diagram. So it consists of 2 stages. 2 stage means 2 stage. First stage RC coupled will be given as input to the second stage. So let me consider this as your transistor T1. So what will be this NPN, right? Okay, now this is your transistor. So normally you will be having a voltage divider biasing across the input. R1, R2, you will be having the collector, that is RC. Okay. Now a coupling capacitor will be given to the input, to which you will be applying the input. Okay. So this will be going on to the common supply. So there will be a pair of RE and CE. Okay. Now the output of the first stage will be given as input to the second stage. So let me take this capacitor as CC, coupling capacitor. So input capacitor I am taking it as C1. Now the output of the first stage will be given as input to the second stage, that is to the base of the second transistor, NPN, right? Okay. Now again you have to repeat the same configuration. You have a voltage divider biasing R1, R2. Along the output you have, collector you have your resistor RC. Along the emitter you have your RE and CE, bypass capacitor RE and CE. Okay, now this will go to your common VCC supply. Okay, along the collector of the second transistor you will be getting your output V out. So this will be giving your V out. So let me take this as transistor T2. Okay. Now let me tell the construction. So in the construction, here I have missed a capacitor, right? In the output you have your capacitor C2 or C out. Okay. Now in the construction, what are the components you have? So you have two capacitor C1 and C2, input and output capacitor. Okay. And you have CC, which is called as coupling capacitor. Input and output capacitor. Now you have, now let me give this as CE1, RE1, RE2, CE2. Okay. R1, R2. Let me give this as R3, R4, so that there will be no confusion. RC1, RC2. Okay. Now all are different. Now you have CE1, CE2. It is also called as bypass capacitor. Okay. Capacitor. Now what is the function of this capacitor? One of the property of the capacitor is, you know, that capacitors blocks DC and allows AC, right? Allows AC. Now see the condition here. Here you are going to apply the input weak signal, which has to be amplified. So now your input to the transistor, you have to give the AC signal, right? So what this capacitor C1 does, we are interested only in the AC component, right? So the capacitor will block the DC and it will allow the AC signal to the base. Similarly, in the output, so I will tell what is happening in between. So in the output, what your C2 does? C2 does, in the output we are interested only in our amplified signal, right? So amplified AC signal. So it blocks all the DC components and it allows the AC components. Okay. Now similarly your CC coupling capacitor, which will allow from the first stage, it blocks all the DC components and it allows it to the allows the AC to the second stage. Okay. So your C1 and C2 is also called by another name, blocking capacitor. Okay. CC is called as coupling capacitor because it couples the first stage. So this will be your first stage, stage 1, and this will be your stage 2, right? Second stage. Coupling capacitor. And CE1 and CE2 are called as bypass capacitor. Why? What is the reason? See here. If there is a voltage drop across this RE, now that voltage drop will reduce your voltage VB, right? So in order to avoid that, all your current, you will be having the current IE here, right? The IE will be allowed to pass through your CE, just like it is, imagine that you have a flyover. Now this will act as a short circuit. It will bypass the signal onto your, through your CE to the ground. Okay, that is the reason why you have your CE, bypass capacitor. Okay, now what are the other components which you have? When we come on to the resistors, you have R1, R2, R3, R4, which gives the voltage divider biasing. So what is the use of voltage divider biasing? You know that when you take the output characteristics of CE configuration, here your emitter is grounded, right? CE configuration, the output current and the output voltage will be varying, right? IC and VCE, keeping input current as constant. So this is your output characteristics what you get. So IB is equal to 10 microampere, sorry, 1 microampere, it goes on varying. IB is equal to microamperes, in range of microamperes. So what is the property you want? You want always your operating point to be fixed in one active region, right? You know that there are three regions of a transistor. So what are the three regions? One is your cutoff region. Here will be your saturation region. Okay, saturation region. Here will be your cutoff region, cutoff region, cutoff region, saturation region, and the third one is going to be your active region. If a transistor has to operate in an amplifier, what is the main characteristic what it has for an amplifier? The transistor has to operate always in active region, right? Active region, so that your operating point should be fixed to, so this region is called as the active region. So your operating point should be constant in your active region, it should not shift. Okay, so the best biasing method is your voltage divider biasing, so that it keeps your VBS constant. That's why you go for this voltage divider resistor. Now what is your any other resistor? Yeah, your resistor RE. RE is your feedback resistor or your stability resistor. Okay, feedback, I can call it as your feedback resistor, which will give the negative feedback to the transistor. Okay, then any, yeah, RC1 and RC2 are your both your output resistors of your individual stages. Now what will be your working principle? Now as I give the V in to your input, the capacitor C1 allows the AC to pass through it. So this circuit along with VCC is used for biasing. Okay, it will be holding the operating point in the stable region without shifting. So now here your your transistor will be having a gain, that is your beta value. The output of the first stage of the amplifier or the first stage of the transistor will be an amplified signal, but it will be 180 degree phase shift, right? So this will be your 180 degree phase shifted signal. Now this signal will be given coupled to the second stage, base of the second stage. Here also the same process happens, and finally you are going to get the overall output, amplified output. So here it will be in phase with respect to that of the Vin, because here you have 180 degree phase shift, so 180 degree plus, so both plus you will be getting 360, which is nothing but in phase with that of your input signal. So what will be your now your overall gain? The overall gain will be equal to AV will be equal to AV1 into AV2. Okay.